You're likely familiar with AI as a solitary assistant, a single chatbot answering questions one by one. By the end of 2026, researchers project that 40% of enterprise applications will run on collectives of AI agents working together in the background, acting as fully independent digital operators. For decades, software companies monetize their platforms using a seat-based licensing model. An enterprise paid a predictable monthly fee for every human employee who needed to log in and use the system. Today, autonomous agents are beginning to automate entire corporate departments. As these systems handle procurement, compliance, and customer operations independently, the necessity for human-operated software seats declines. To survive this erosion of seat-based revenue, software vendors are adopting outcome-based pricing models. This allows organizations to purchase completed units of work or successful resolutions directly, shifting corporate expenditure from human payroll to scalable digital labor. A solitary AI model operates through one central brain. It must manage text and visual perception, call external APIs, and maintain a consistent memory of changing states, all within a single processing stream. When tasked with heavy corporate logic, such as auditing hundreds of pages of financial records, this single stream of logic hits context limits. The system creates reasoning bottlenecks and begins to hallucinate facts to fill the massive gaps in its memory. Efficient businesses break complex operations into specialized roles. To make AI reliable at an enterprise scale, developers are building multi-agent systems to divide the labor among distinct, focused specialists. The success of these systems depend on how they organize their digital workers. The most common baseline is a centralized architecture, which functions like a traditional corporate hierarchy. This chart shows how a central orchestrator agent takes a primary task and decomposes it into isolated domains. It delegates the work to subordinate specialists concurrently. For parallel workloads, like evaluating balance sheets and market comps, this boosts performance by 80.9% over a single-agent baseline. However, many tasks require a strict order, where Step B cannot start until Step A is complete. In these cases, the orchestrator reconfigures the specialists into a linear chain, passing the data packet one by one. This sequential passing creates an information fragmentation tax. Because global context must be compressed and transferred across multiple messages, the system erodes the information fidelity at every handoff. In these sequential workflows, performance can drop by up to 70%. Architecture determines the outcome. Parallel agent teams excel at broad environmental exploration, while complex sequential logic remains more effective when handled by a single agent. Even with the right architecture, different agents face an interoperability problem. If a compliance agent and a database agent are built by different vendors on different codebases, they cannot natively assign tasks to each other. The industry is solving this through standardized communication protocols. Anthropic's Model Context Protocol standardizes how models connect to local files and databases, while Google's Agent-to-Agent protocol manages task delegation across competing frameworks. These protocols act as a universal translator. They allow one agent to securely hand a structured artifact or a specific task lifecycle to another, regardless of the underlying software stack. Without these horizontal standards, developers must write custom wrappers for every single inter-agent exchange, leaving multi-agent networks isolated and difficult to scale in production. Chaining independent, non-deterministic agents together creates a specific engineering dilemma known as the reliability paradox. This equation reveals how individual error rates multiply across a sequence. If you chain 5 agents that each have a 95% success rate, the system's cumulative reliability decays to just 77% under real-world transaction volumes. This mathematical decay creates compounding execution latency and increases cloud computing costs. Furthermore, a 5-agent network introduces 20 possible attack vectors, where malicious actors can inject prompts, significantly widening the attack surface for the entire organization. Chaining smart AI models together creates a fragile system. To maintain reliability, architects must implement automated circuit breakers and single-agent fallback paths to manage the complexity. As these systems transition from giving recommendations to executing financial transactions, a psychological risk emerges: automation complacency. As multi-agent networks demonstrate high reliability, human operators tend to decrease their vigilance, approving system actions without verifying their accuracy. This lack of oversight allows minor errors to align across multiple validation layers. It mirrors the Swiss cheese model of failure, where small bugs slip through unnoticed until they trigger a systemic crash. Regulators are responding with strict accountability mandates. Under the European Union's AI Act, high-risk agent deployments must include interfaces allowing a person to oversee, understand, and override the system in real time. In the US, regulators like the Federal Reserve and the CFPB are applying similar standards. If a financial institution cannot explain the exact data lineage and decision logic of an automated agent, that system cannot be deployed. These mandates force enterprises to treat autonomous software with the same risk management and liability standards applied to high-risk human employees. Because autonomous agents now query APIs and execute payments, identity has become the primary control surface. Every agent must authenticate its identity using cryptographic tokens mapped to specific role-based access policies. This identity layer enables the human-in-the-loop checkpoint. An agent can prepare a complex financial disbursement, but it is physically restricted from initiating the transfer until an authorized human reviews the audit trail and grants permission. The value of professional work is migrating towards the orchestration, management, and oversight of these autonomous digital operators. Future success depends on acting as the critical safety valve for the digital team.